And now I'm going to give the stage to Alice with our first talk.
Hi there, I'm
Hey,
Alice.
Alice.
If you haven't, I'm sure most of you already know me. I'm one of the maintainers of Bevy, and I'm gonna jump right into
Perfect.
the talk because I'm here to answer a question that you have today. It's what the fuck is reflection? So you may have heard us talking about reflection. Oh yeah, we have Bevy reflect and we have weird macro heavy code and all of that, but it can be an intimidating topic. So in order to kind of get an understanding of where my audience is at, I did a informal poll of one professional Rust developer who happens to be my girlfriend. And this poll revealed that professional Rust developers think that reflection has something to do with type information. It's definitely complicated. It's probably important for Bevy's internals somehow. They don't really have any clue how it works. They're not sure why it's useful, but they know for a fact that it's probably cursed. So let's break it down into really simple terms. Let's try to understand what this is and why it's useful in a simple way. So when I was trying to write this slide and doing my research, I was like, I should make a succinct summary of what reflection is. But turns out David Drysdale from with his effective Rust book thing. It's really great. You should read it. Has a great quote, which is reflection is the ability for a program to reason about itself at runtime. And in Rust, we usually mean that the program is reasoning about its type information at runtime. Um, and we can use this to build powerful abstractions that work around the language limitations, or they're used to interface with external tools, things like serialization, where you have saved games and networking. In terms of abstractions, we have things like dynamic value editing. So if you've ever used Bevy Inspector GUI and twiddled the values and watched them dynamically change, that's all done through inspection, through reflection. So then you don't have to write getters and setters for everything. And finally, the other third use case we're going to talk about today is Bevy's new runtime defined component and resource types, which is coming in 0.13. So we're talking about reasoning about a program itself at runtime. So what information can you actually access at runtime in Rust with today's code? So within Rust itself, we have some very basic but very useful primitives for reflection. So the most important one is type ID. Type ID is just like an opaque identifier, which is kind of like how entity works, where every single type will have its own U64 or something, and that number will tell you what the type is. And critically, this is completely opaque. There's no rhyme or reason to it, and generic types, things like a vector of f64 versus a vector of u8, these will each get their own type ID and they won't have any relation to each other. So very useful as a stable identifier, but doesn't give us anything else. The next thing that we get is this trait called any, and the any trait is in some ways kind of the ultimate trait. Everything can be coerced to an any. And what you can do with it with an any trait object is you can downcast it into a concrete type. You say, okay, I want my type out, and then you say, okay, please downcast it. I promise you that this box is actually a my type, and then you unwrap it and you hope that you didn't screw up any of your accounting. But really quite cool and foundational. There's also type name, which gives you the name of the type, but this is fundamentally unstable and they make no guarantees and it's for debug information only, and you definitely shouldn't do anything fancy with it. And then two other ones that I'm gonna argue are reflection, which is the size of and offset of method and macro in this case, and these will tell you the layout in memory of your types. And Bevy actually makes use of these when trying to store its own dense storage of our component and resource types. So we also have, though, we're not limited to the tools that just Rust gives us, right? We can write our own, reflection libraries, and in particular, we have Bevy Reflect, which is a runtime reflection library. So it'll let us at runtime, so while the program is running, get information about the types of our objects. So Bevy Reflect fundamentally operates on types, and on instances of those types, and it doesn't work. It doesn't actually. You can't reflect traits currently because there's no way to store the data or anything. But you have you get information about, like, is this a struct? Is this a tuple? Is this an enum? It's kind of the most basic information. Then you can get out the field names and the types of all of those fields for the for all of the fields of your structs. You can kind of abstract over these over the different types of data structures you might have. You might want a list. You might want a map. You may want to iterate over a list. And you can do this in a generic way. I'm sure the functional programming people are like, "Oh, I know that. It's a hack, but yeah, it's good." And it'll also give you information about the path of the type. So where is this at? It's like Bevy ECS system query or whatever. Like that's the type path. You can also reflect documentation, which is a very cool trick that I was very surprised to see worked when we got the PR for it, but I'm pleased it exists. And finally, you can, if you make a shadow trait and the trait is type safe, object safe, and you manually register the trait, you can even get information about which traits are implemented for that type. So if you're a beginner to Rust or beginner to programming more broadly, you'd be like, okay, yeah, sure, this makes sense. It's kind of hand wavy, but yeah, okay, sure, we could do this. But if you're a Rust expert, if you've been in the community for a long time, you'll have some questions because Rust doesn't have reflection. Like that's the line, and it's kind of basically true. Like we don't have compile time reflection. We don't have a first party reflection capabilities. It's not great, but we do what we can. So traditionally, reflection libraries, reflection tools in other languages are implemented by the language themselves. So things like Java and Scala and so on. What they'll do is they'll either have the type information passed in at runtime, or you'll be able to hook into the compiler API. And neither of those things are particularly possible in Rust. So the compiler API in Rust is churning and private and wildly unstable and not very useful. There's talks of this upstream in the Rust project to change that via a process called libraryification for when you really like to get turned into a library, I guess. But that doesn't exist yet. And finally, the type information is erased at runtime. Like all we get with our types is that debug type name and the type ID, and everything else is totally stripped out for speed and memory usage and all of that. So we don't inherently get access to this. But we can work around this. What we can do is we can make our own reflection framework by modeling Rust type system using Rust type system. And in order to populate that information, we write our own compiler. We use derived macros. We look at the actual source code of those structs that you're defining, and you say, okay, what are the fields? What are the field names? What do they store? And you break it down recursively until you have until you back down to the primitives that we've manually said, okay, this is a value that we can reflect, and we know how to represent this. And then you have these complex nested structures that recurse down until you have a full way to capture any struct in Rust, hopefully. And then we take all this information that we generate through the derived macro, and we're going to register it into a type registry, which is in Bevy, generally stored on the world in one form or another. And then you go and you say, okay, I want information about this type. Tell me metadata about this type. And so in this way, we can go and actually access this type information at runtime, basically by writing our own compiler and bypassing everything that Rust wants us to do. But that's okay, because macros are powerful. So let's get into this a little bit more tangibly. So this is kind of a mid-level struct that we find in Bevy Reflect. I thought this one was very interesting and very approachable. And so we start off at the top above this at the reflect trait, which is kind of the central trait that says, okay, everything that's reflectable can be represented as a dyne reflect trait object. And then from that, we can get things like its type info. And the type info is information about the type, shockingly. And this information, this type info, is itself an enum, and one of its variants is enum, which stores a struct called enum info. And that's what you see over there on the right-hand side of the screen. Although it mirrored. Anyways, so in this, what do we see? Okay, so we see the type path. We have something called the type path table, but this fundamentally lets you look up what the type path of that type is. Then you have a type ID, which is, again, that stable identifier. you have the variants. So we have a box slice variant info. So basically an iterator over the information of the variants. And this will give you the names of the types. They'll give you the names of the variants. They'll give you the type of them, and then you can have nested types within there, and you'll recurse down. And then you'll have a way to quickly look up the variants by their name. That's what the variant indices is for. So, and then the other thing that you'll notice there is we have a feature flagged field called docs, which will just give you an option to a string. So then if you have the docs and then the docs were properly generated and the docs exist, you can just pull them up you can just pull them up at runtime and say, hey, what's the docs for this type? And I'm very excited to use that for the editor. So you kind of get some sense of how this works and everything, but what is it actually good for? So let's go into one of the most common and straightforward uses of reflection, which is serialization and implicitly deserialization. So serialization is the process of converting data into a type that can easily be stored or transmitted. So things like save games, where you're trying to store this complex data onto disk, or things like networking, where you're trying to produce these packages in an efficient form and then send them out and then deserialize them back into a game object that you can work with. And in order to serialize things, we need to understand what its shape is, what its field is, and especially to deserialize things. And so you'll need to know the fields, the field names, the type of each primitive value, and some sort of representation that matches with like what JSON or RON wants, which is like, is this a list like? Is this map like? Is this value like? And so Bevy Reflect by itself can be used entirely as a standalone serialization library. No Serday needed. And again, all of this information is generated through that derive macro of reflect, which will go through and parse your fields and so on. So let's talk about a different application, something a little bit more complicated, but very, very, very useful for games. So this sort of tool, Bevy Inspector GUI, if you haven't used it, you should. It's great. Put it in all your projects. You pop it up, and you say, okay, tell me the list of all of the entities that are in this game in my scene right now, and what are the components, and then you can go and you can actually live edit their different values. And this sort of ad hoc dynamic typing and like value editing and stuff is really characteristic of reflection and of dynamic typing. And you could do it without reflection. It would just be an infinite amount of boilerplate that you need to constantly update every time you add another new thing. But with the way that Bevy Inspector GUI is implemented, and with the reflection, and hopefully how the equivalent tool is first party tool works, is it looks through the reflection, it parses the values, it says, okay, it's going to look like this, and then it says, okay, yeah, that's a float field in there, and this is the name of it, and it can go and automatically generate and populate these menus for you. And so this abstraction is incredibly powerful and a huge time save for game editors. And fundamentally, this is a huge part of why Kurt initially built Bevy Reflect, is because he knew that these tools are essential for game development, and we can't do it's with the existing Rust ecosystem, we couldn't do things like this comfortably. Finally, we'll go into the most advanced, the most galaxy brain application of reflection in Bevy today. So this is something you may have heard people talking about, where they have a different language that they want to interface with Rust, and they want scripting or modding support, and they're like, man, I really just want runtime defined components and resources types, so you can just go and you can just add more, and they'll work just like any other Bevy component, but they're defined at runtime, and they can be defined from outside of Rust. And that's fundamentally what this application is useful for. I mean, it's probably also going to be useful for relations, but relations uses lots of curse magic. So what you can do is, the way it works is that when ECS data, so components or resources, are inserted into the world, they'll be initialized with a component ID. So a component ID is just a unique identifier, a unique opaque identifier. We love unique opaque identifiers in this house. And they'll get a component ID, and which is sometimes a type ID, but if it's a runtime type, It's a runtime defined identifier. Then we're going to go and we're going to store this type information using reflection in the world as a component info. Then within our world, ECS world, because we really like performance, we're going to go and we're going to have a dense, it's called a blob vec, for all of our contiguous arrays of nicely aligned data. And again, we're going to look at the component information to figure out, okay, how big are these types? What are the different pointer offsets into the fields? And then we'll use pointers to actually operate with those. But because we're using these opaque identifiers and we're using pointers anyways, we can just expose this information to the scripting language with unsafe APIs. And you can just say, okay, hey, the scripting language can say, okay, please go and modify the value of this component at and this field of this component of this entity from to, and please set it to this F32. And it can just do that. Like there's no, and it can do that with very, very, very little performance overhead. Or at least certainly a lot less than you expect it to require. So we're still fleshing out this API. We're still going to make it. We still have to stand off the left corners. But coming in Bevy 0.13, I think all of the fundamental pieces are there. We have all of this runtime type information, and critically, we have the ability to construct queries dynamically. So, in conclusion, let's talk about this. So, should you, as random Bevy user, as Bevy library developer, as Bevy engine developer, should you use reflection? So, the first pro for reflection is that it's wildly flexible. You can do anything with it. You can be like, okay, I'm gonna go and I hate this compiler error, or I hate this the fact that traits aren't exposed at runtime, and I really want to query over traits. And you can just say, no, I'm just gonna bypass that by adding more information to the reflected type information, and then just asking for it. The first most important con is that it is wildly flexible. It's very easy to galaxy brain yourself and use reflection when you don't need to, and create this like horrible unmaintainable mess. Reflection is definitely a tool of last resort, but you know, when you're at your last resort, it's much better to have something than to just have to give up. And on that note, some of the other cons of reflection are, the biggest one is that it has a runtime performance cost, at least for most applications. There's several levels of indirection. You have lots of lookups. You're saying, okay, please look up this type of information and then convert it and then convert it and then convert it, and then you can do the thing that you want it to do. And if you can avoid that, it's faster to just not do all of those intermediate lookups. If you worked with reflection in Bevy, you'll also be aware that there's a fair bit of boilerplate involved. You have to drive reflect on everything. You have to make sure it works. You have to make sure that the orphan rule doesn't bite you, because the orphan rule sucks. And it's like, okay, yeah, you don't own that object. You don't own that type. You don't own that trait. Too bad. You have this cool third-party library that's not designed to work with Bevy, and you want to reflect it. Too bad. And then you have to go and actually register your types in the app or the world. It only works with types that have a static lifetime, because that's a requirement for to get a type ID out of it. And it only works with object-safe traits. So object-safe traits are basically ones where you take self or ref self or something in each of your trait methods, so then you have a place to, I believe, store the vtable information. But reflection is really good if you need to abstract over the type system in really complex and abstract ways. Where if you're doing things like making an inspector, if you're making trait queries, if macros, or maybe networking, or like a remote editor communication API. Like, yeah, this is a pretty good tool for that. Like, if you're working at like galaxy brain levels of abstraction already, like this might actually be the tool for you to work with. And it's also, if you're trying to translate Rust data into not Rust or vice versa, like reflection is just the tool you should use. Like just reach for it and poke around at how we do our scene serialization, poke at how people do networking stuff. This is the tool. And then the final con is that, yeah, having reviewed PRs and made contributions to Bevy reflection is definitely probably cursed. The beginners are correct. So yeah, that's my talk. I have a bunch of further reading linked. I'll promote my I'll post my slides with better formatting online, and there's a bunch of interesting resources in terms of both crates and in terms of um, further more in-depth explanations that are really worth poking at if this topic was interesting to you.
Amazing, Alice. That's a crazy topic, and I can't wait to play more with it in 013. So there's a bunch of questions. Let's
Right.
start with the most high upvoted one. Can reflection ever fail at runtime in any way, or are there any common problem situations to look out for?
Yeah. So reflection. So generally speaking, there is a lot of option types. There's a lot of result types, and you need to be careful that when you're actually that you haven't screwed up your mapping between the different types. And generally speaking, you're just throwing a hash map of whatever string or identifier you want into a type ID, and then you use the type ID as your primary key. But if you screw that up in any way, and then you're just unwrapping all over the place, like yeah, you will get panics. You will screw up, or you'll get failures. The other biggest problems that I have with reflection is that it's very, very easy to forget to derive things, or forget to initialize a type thing, and then you're like, why can't my scene serialize? Why can't I do? Why isn't this showing up in my trait query? All of that, it's because you forgot to register to the type registry, and we can't fix that easily. We need changes upstream in Rust to, it's called life before main, where you'll go and you'll actually inspect the source code of your whole program, and then go and insert go and be able to do things like register all of the types that implement this thing. And we can't do that. There's a crate called inventory, which can kind of do this, but it doesn't work on Wasm, so we don't use it.
Is there any chance that we might get that into upstream?
This is something that the Rust leadership is sympathetic about and like is open to solutions for this. There's also some sympathy and controversy around compile time reflection, which would help a lot with a lot of these things. But like with all things with upstream Rust, I will believe it when I see it. Organizationally, they get things done. They don't necessarily get the things that they want to get done. So.
Got it. Okay. Another question is, do I understand correctly that compiler information will be exposed at runtime via proc macros then? Is this used internally or only for world serialization and inspection?
So generally speaking, you can run you can use component resources and the standard ECS stuff all completely without reflection. We use things like size of and stuff inside of our internals, but there's no proc macros involved there. So the reflection is only for advanced use cases and for serialization within Rust itself, within Bevy itself.
Gotcha. Okay. And someone was wondering about component ID and if it could be used to register components for each enum variant to be able to query for enums by value.
Yeah, and so that's definitely something we could do. The problem there is that we would need to, so we could absolutely query for enums by value. Like that's totally feasible. We wouldn't be able to use the same syntax that you're used to, where you just say ref option none or whatever. Like this won't work because in order to generate those the world query trait implementations, we need to actually have a concrete type that Rust recognizes in order to implement that trait on. So what we'd have to do is we'd have to probably use this, expose this only through dynamic queries, and then you have to pass in a concrete value, which may actually work. And that would be something I'd be interested in seeing explored. However, in order to get that working properly, you're going to want to have an index which is reliably updated and synchronized and efficient and actually faster than just iterating over the list and so on. So like this is something that we could do, but it's like a 5-part research project if anybody's interested.
Yep, gotcha. Okay, last question. I guess we have to defer the rest for maybe at the end if people have more time to stick around. So how much would a better built-in Rust reflection benefit Bevy? Would it make crates like SERDI obsolete?
Yeah, so this is a complex question. I would definitely defer to people like Mr. GVSG, who is much better at reflection than I am. But my understanding is that the primary benefit that Bevy would see from compile time reflection and built-in reflection from Rust is not having to deal with the orphan rule. Not having to deal with the orphan rule would be really nice, and shorter compile times, because this could be built into the compiler. We could hook into what they're already doing. We could, rather than generating a pile of code for each of them. And yeah, like there's absolutely a world where things like SODE representations are basically automatically generated for every single Rust type, and this would be great for us because we want that information too, both for serialization and for not. And then you could have, manual overrides for custom, highly efficient or specialized serialization formats. But like generally speaking, this could be done. Assuming you were able to get the compiler internals to cooperate, which is easier said than done, both technically and organizationally.
Alice, is there a common way to add more reflectable metadata like min-max values for editors?
Yeah, so I actually cheated a little bit, and Mr. GVSV was chatting with him during the other talks, and he says that this should actually be quite feasible to implement by just shoving it into the type data, which makes sense to me. I've seen that the Bevy Inspector GUI does something very similar with its own trait. I'm definitely, as we move closer towards a actual first-party inspector editor quasi thing, to making sure that works first party without needing an additional trait.
Is Bevy Reflect basically complete, or are there more features that we are looking to add to it?
So I'm not a reflection SME. I merely maintain it. I merely help out with reviews mostly, and occasional fixes. But Bevy Reflect is basically functional, basically usable. There's a lot of like rearranging deck chairs, making things nicer, making things prettier. The only big the major structural change that I would like to see is recursive type registration, where you go and when you register a type, it then registers every other type that's in there and has been seen, just to reduce boilerplate. And the other thing that I would like to see is the remote reflect work being done, where you use questionably cursed things to kind of implement reflect on foreign types, which was a technique stolen by Serde, and it's very tricky to get the details right, so we haven't landed that. But both of those are examples of like meaningful things we can add to Bevy Reflect, but it's certainly a lot more mature than something like Bevy ECS, where we have 50 large outstanding features where it's like, yeah, sure, I would like this feature.
Will reflection ever be mature enough so that we can deep clone entity components, or is that more of a storage principle?
Yeah, so talking this over with Mr. GVSC again, who's been fantastic. Basically, we already have the ability to clone arbitrary data types using the reflect clone value, which will then go and recursively actually instantiate new things. It's kind of cursed because it doesn't actually require a clone bound; it just reflect bound, so you can actually clone objects. You can clone objects and deep clone objects in this way without needing the clone trait per se. So it already exists.